Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides an introduction to linear regression analysis and modeling. Let's get started. Let's review some basic definitions that are essential for us to know in order to do well with linear regression. So we have a collection of data points that we're putting on a scatter plot because these data points are really ordered pairs. So there's X and Y values that are unique to each data point. And we put these on a scatter plot and we create a line of best fit, which is a line that best fits the data points on the scatter plot. This line is also known as the regression line because it's the line produced by the regression equation. It's also known as the least squares line because the methodology used to calculate this line, to get the equation of the line, is based on a method called the least squares method. So of course the line that comes out of that method is known as the least squares line. Now the regression equation is simply a mathematical equation describing the relationship between x and y hat. Notice I said y hat and not y. Y hat is this y with a little caret on top, and the little caret looks like a little hat, hence the name y hat. Now both x and y hat have their own different names. X is also known as the explanatory variable because it's the variable most responsible for the explained variation in the regression equation. It's also known as the predictor variable because its value produces a prediction from the regression equation. So it's the variable that allows us to make a prediction. And it's also known as the independent variable because it's independent of anything. It can be whatever we want it to be. We select x to be what we want it to be. The y hat is also known as the response variable because the regression equation produces y hat. It is the response the regression equation provides based on whatever input we give to it, that input being the value for our x. Y hat is also known as the dependent variable because its value depends upon the value that we choose for x. So different names, but the same sort of folk here. So no matter what name we're going by, you can know what's going on if you're familiar with what things are called. Here's a table listing some further differences between population parameters and sample statistics. Notice y hat is the response variable for the sample regression equation, and the population regression equation is what we use to describe y. Notice also that the population parameters are expressed with the capital letter beta. This is a Greek letter. And the sample statistics are expressed with a lowercase letter b. Y-intercepts have a subscript 0, slopes have a subscript 1. Once you kind of get the pattern going down here, it's not hard to see that the regression equation, whether you're talking about a population or a sample, follows the slope-intercept form y equals mx plus b, where m is the slope of the line and b is the y-intercept. Let's take a look at some of the requirements that we need to have satisfied because our methodology for linear regression is based on certain assumptions. And in fact, they're the same assumptions that we had when we looked at linear correlation. So first, we need a sample of paired data that is a random sample of quantitative data. Next, a visual examination of the scatter plot will show a straight line pattern or something not too far from it. And any outliers that are known to be errors must be removed from our data set. Now, once we meet these above requirements, we can use the following formulas to derive our regression equation. First, the slope. We get the slope by taking the linear correlation coefficient, multiplying by the sample standard deviation for the y, and then dividing by the sample standard deviation for the x. Then once we have the slope, we can calculate the y-intercept, we simply multiply that slope by the sample mean for the x values, and then subtract that product from the sample mean for the y values. This then gives us the y-intercept. Once we have the slope and the y-intercept, we can then substitute into the general form, y equals mx plus b, and we can derive our regression equation. Let's take a look at this example that we've been looking at for the past few mini lectures that is looking at a relationship between shoe print length and height. So we know from previous mini lectures that there is a linear correlation extant here, but what is the linear regression equation that describes that relationship? Let's look to see how we can derive that. So previously we showed that our requirements are met, so we're not looking to reinvent the wheel here. But now that we know the requirements are met, we can go ahead and use our methodology. So we're going to calculate the slope of our regression line. So here's our general equation. We substitute in values from our data set, and these are easy to calculate. You put them in StatCrunch, or you can calculate them by hand. Either way, these are the numbers you get. When you punch these out on the calculator, you get 1.634. Now we've got the slope, we can get the y-intercept. So here's our general form for the y-intercept. I plug in the values for that equation, and out comes 128.91. This then is the y-intercept. So now I've got the slope and the y-intercept. I have what I need to write down the equation for our regression line, and we do that by substituting into the general form. So here's the general form. I'm going to put in the values that I have. So height is my y variable. Shoe print length is the x. So we put in the shoe print length and get height to come out. Notice the y-intercept and the slope and where they're positioned. So the 120.91 goes by itself, and the 1.634, which is the slope, is multiplied by our x variable. In this case, shoe print. You graph this out, here's what the data look like. Now, if you use software, you're going to get the same answer that you come out here. And, you know, I'm a big fan of using software because I'm a lazy engineer. What can I say? It just makes things easy. Put the data in, let the calculator do the number crunching for you. That's what I'm all about. So when you do that, here's the output that comes out. Notice the regression equation. Here's the slope. It's the same as the slope we calculated. The intercept is the same. And lo and behold, here's our regression equation. Notice it's the same that we have listed down here. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.